everyone, welcome to Learning at 11th Hour. In this video, I'm going to continue about two-port networks, and we'll be discussing about the hybrid parameters, and we'll see how we can use the hybrid parameters to establish the relationship between the input and the output of the two-port networks. So whenever I hear the word hybrid, the first thing that comes to my mind is a mixture of two different things. Having said that, let's get into the video to see how we can frame the equation for the two-port network using hybrid parameters. We'll also establish the relationship between the h parameter and the z and y parameters, and we'll see the condition for reciprocity for the hybrid parameters. In the end, I'll be showing you an example problem and see how we can solve that particular numerical that involves h parameters. So let's go into the video. Let us look at this two-port network and try to write out the equation in terms of hybrid parameters. So when I say hybrid, like I said, what comes to my mind is a mixture of two different things. So here on the input side, the matrix is going to consist of both the input and the output values. So here we will have V1, I2, and that would be equal to H11, H12, H21, H22, which is the H matrix, followed by I1, V2. So when we write it out as equations, we can represent it as V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. Having said that, let's try to enunciate each of these h parameters here. So h11 can be found out if I consider V2 is 0. So when I say V2 is 0, it means I have to short circuit the second port. So when I do that, when I take V2 is equal to 0, what I get here is V1 by I1. This is provided V2 is equal to 0. So this particular parameter is also called as the short circuit impedance of port 1. On the other hand, if I consider I1 to be 0, then I can find the value of H12 in this manner. So I'll get H12 is equal to V1 by V2, provided I1 is equal to 0. So if we look at this is actually a gain. Okay, so if I have a ratio of the output voltage to the input voltage, that would be called as the voltage gain. But in this case, we have the reciprocal of it. And when I say I1 is equal to 0, it means that port 1 has got open circuited. So this parameter is basically going to be called as open circuit because I1 is 0, and reverse voltage gain. Reverse voltage gain. Now let's look at the second equation and try to find out H21 and H22. So here if we see, we have say H21, and that can be obtained by considering V2 is 0, which means again I'm considering that port 2 is short circuited. So therefore H21 is I2 by I1. This is nothing but the short circuit current gain. So this is provided V2 is equal to 0, which means this is the short circuit condition. So this is also called as the short circuit current gain. The last parameter is H22. So when I have H22, this can be obtained by considering I1 is 0, which means open circuiting the first port. And what I get here is H22 is equal to I2 by V2, provided I1 is equal to 0, and therefore I can call this parameter as open circuit, and this is nothing but an admittance parameter, and this is at the output terminal, considering port 2 to be my output. So this is output admittance. So having said that, these are my four H parameters that make up the H matrix. Let us now look at the relationship between the H parameter, the Z parameter, and the Y parameter. So now we'll write out the Z parameter in terms of the H parameters first. So here Z11, Z12, Z21, and Z22. This can be written as delta H by H22, H12 by H22 minus H21 by H22 and 1 by H22. Here we see that delta H is given as delta H is equal to H11 H22 minus H21 and H12. Now, having said that, we can also write the Y parameters in terms of the H parameters. So, Y11, Y12, Y21, and Y22. I'm going to write this out in terms of the H parameters. Here, this is going to be 1 by H11 minus H12 by H11. This is H21 by H11 and delta H by H11. On a similar note, we can establish the H parameters in terms of Z and Y. So if I want to write it in terms of the Z parameter, I'll be able to write it as delta Z by Z22, Z12 by Z22, Z21 by Z22, and 1 by Z22. So there is a minus sign here. It shouldn't be missed out. So this is the H parameters in terms of the Z parameters. And we can write the same thing, the H parameters, in terms of Y parameters. So that would turn out to be 1 by Y11 minus Y12 by Y11, Y21 by Y11, and delta Y by Y11. So it's pretty interesting to note that if you want to write the Y parameters in terms of the H parameters, all you need to do is you have to replace the Y with H in this. So there's this relationship that exists which you can use to remember, because every time we cannot derive and arrive at this. So that's one way to remember. Similarly, if we look at the relationship between the Z parameters in terms of H and the H parameters in terms of Z, we see that all we need to do is we need to replace the H and the Z. That's all. And even for expressing delta Z and delta Y, so delta Z will be Z11 Z22 minus Z12 into Z21, and delta Y also will be Y11 Y22 minus Y12 into Y21. So this is the relationship or the interrelationship between the Z, Y, and the H parameters. Let's move on to deriving the condition for reciprocity in terms of H parameters. So to establish the condition for reciprocity in terms of the H parameters, we are going to look at these two uh, cases. In the first case, we have the linear passive network's first port being connected to Vs, voltage source, and the second port is short circuited. So current minus I2 dash is flowing through the second port. Similarly, in the second case, if we connect Vs at port 2, then current minus I1 dash should be flowing through the first port. And in that case, I2 dash by Vs should be the same as I1 dash by Vs. When this condition is satisfied, we can say that the circuit is reciprocal. So let's try to write out the H parameter equation first. So we know that V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. Now let's look at this scenario, first scenario A rather. So here we see that V2 is going to be equal to 0, and I2 is actually equal to minus I2 dash, and V1 is equal to Vs. So let's incorporate these into these equations and see what relations we get. So here we see that Vs is equal to H11 I1 plus H12 into 0. And when we incorporate these conditions into this equation for I2, we see that minus I2 dash is equal to H21 I1 plus H22 into 0. Now, our aim is to obtain the ratio I2 dash by Vs from this. So, to do that, we can just divide equations. If I call it as equation 1 and 2, if I just divide these two, I'll be getting a relationship, right? So, if I divide I2 dash, that is equation 2, divided by equation 1, okay, there's going to be a minus sign which would be taken to the other side, right? So I'll be getting this as minus of H21 by H11. So that is I2 dash by Vs. Now incorporating the second scenario into our H parameter equations. So let me write out the equations one more time. V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. Looking at this configuration, we see that V1 is equal to 0, V2 is equal to Vs, I1, which is going into the network, and it's opposing I1 dash. So I'll call it as minus I1 dash, which was exactly the scenario over here. So this is actually the direction of I2 going into the network, and I2 dash is opposing it. So which is why we write I2 as minus I2 dash over here. So let's go back to this. Here, let me replace it in these equations. So I get 0 is equal to H11 into minus I1 dash plus H12 V2. V2 here is nothing but Vs. So I'll replace it with Vs. And I2 is equal to H21 into minus I1 dash plus H22 into Vs. Now, if I simplify this particular equation, what I would get here is H12 into Vs is equal to, taking this on the other side of the equation, H11 into I1 dash. And from here we need to establish the expression for I1 dash by Vs. So this can directly be obtained from simplifying this particular expression which we've got. So if I just take Vs to the other side, what I get here is H12 by H11. So if I equate I1 dash by Vs to I2 dash by Vs, I'll be getting the condition for reciprocity. Here I2 dash by Vs was obtained as H21 by H11, and on the other hand, we've got I1 dash by Vs as H12 by H11. So when we write it out, let's equate it. We'll get it as H12 by H11 is going to be equal to minus of H21 by H11. So I can just cancel out the H11 from both the sides, and we arrive at our condition for reciprocity in terms of the H parameters as H12 should be equal to minus of H21. Let's quickly look at an example numerical that involves the H parameters. So in this example, this is the kind of network that we've been given, and we have been given the H parameters in this manner. So we see that H11, the units of H11 is ohms because this is the open circuit input impedance, and H22 is the output admittance, therefore it is more. H12 and H21 are both gain parameters. So it's a ratio of two voltages or two currents. So therefore they don't have any units. Now we need to obtain the ratio V2 by V1. So to do that, first let's write out the equation for this particular network in terms of H parameters. So we have V11 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. So looking at this, what we need to do is we need to find the ratio of V2 by V1. So we have both V1 and V2 in our first equation. The only thing is if we are able to write out I1 in terms of, again, V2, then our problem will be solved. We can just take V2 common on the right hand side and bring it down, and we'll get a ratio. So to do that, we are going to take the help of the second equation, that is I2 equation, and also we are going to apply KCL at the output loop. So here we see that this current I2 is in this direction. So therefore, the drop is going to be like this, and this drop is here. So effectively applying KVL at port 2, what we get here is we get V2 plus 2000 I2 is equal to 0, or V2 is equal to minus 2000 I2. So now we've got a relationship between V2 and I2. So we can simply replace I2 over here and get I1 entirely in terms of V2. How do we do that? So we see that I2 can be written as V2 by 2000 with a minus sign. So I've replaced it here from this particular equation. This is equal to H21 I1 plus H22 V2. So let me take this V2 term to the other side. So what I get here is minus of V2 into 1 by 2000 plus H22. And this is equal to H21 I1. So instead of keeping my H21 over here, if I bring it down to the denominator on my left hand side, so I would be getting this as divided by H21. So I have I1 in terms of V2 and the hybrid parameters. The H parameters are already given in the question. So now I can replace I1 over here with what we've just got. So to do that, let me just write it as V1 is equal to H11 into minus V2 by H21 into 1 by 2000 plus H22. This is I1, right? Plus H12 into V2. So if you see, we have V2 in both of these terms. So I can take V2 common, and what I will get here is V2 into minus H11 by H21 into 1 by 2000 plus H22 plus H12. So this is what we get. Okay. Now we can simply take V1 to this side and this entire term to this side. So if we are able to compute the reciprocal of this particular expression by replacing the h parameters given in our question, we will be able to compute the ratio of V2 by V1. So on replacing these values, the ratio that you should arrive at is minus 200. So that is the answer for this particular problem. So that's all with today's video. I hope the H parameters concept is clear to you all. Please do subscribe to this channel for more such videos on circuit theory. Thanks a lot for watching.